Hi grade 10s, today we're going to be working through a past paper on electrostatics, so let's jump right in. Here we have two identical insulated spheres, X and Y, suspended by threads from a ceiling and are held at a small distance apart as shown in the diagram below. So you can see that sphere X, which is the positive sphere, has a charge of 4 times 10 to the negative 18, while sphere Y has an excess of 30 electrons. So the first question asks us to calculate the magnitude of the charge of sphere Y. So if you think back to all of your equations for this topic, you know we're going to be working with the equation N is equal to Q over E. So N is our number of electrons, Q is our charge, and E is the charge of our electrons. All right, so here we're trying to calculate the charge of sphere Y, and we're going to be doing that because they told us that the number of electrons that we have is 30. So we're going to say 30 is equal to Q over our charge of our electron, which is a constant, which is negative 1.6 times 10 to the negative 19. Then we're just going to cross multiply over there to get our charge, and our answer is going to be negative 4.8 times 10 to the negative 18 coulombs. Cool. Jumping into the next question. So now they tell us that the spheres are released and they move towards each other. They're oppositely charged, so we know there's going to be a force of attraction, so they will move towards each other, right? 10.2, they asked us to give a reason for why X and Y will move towards each other, and like I just said, they are opposite charges and opposite charges attract, right? So let me just write that down. Opposite charges attract. Cool. The spheres are allowed to touch each other. After touching, they move away from each other, right? So they may ask us for 10.3 to firstly state the principle of conservation of charge in words. So that's just one of your definitions that you should know. So the net charge in an isolated system remains constant. So what that means is that we're not going to lose any charge within the system when they touch or anything. The total net charge is always going to stay the same, even if there is that transfer of electrons and transfer of charge. Right? So then 10.4 asks us to then calculate the charge on each sphere after they have been separated. And the way we do that is by using the formula Q net is equal to the sum of our two charges and divided by the number of charges. So in this case, we have Qx plus the charge of y, and since there's only two charges, we're going to divide it by 2. So our net charge is going to be 4 times 10 to the negative 18 plus negative 4.8 times 10 to the negative 18. Remember, this charge is the one that we calculated in 10.1. Then we're going to divide that both by 2. And our answer is going to be negative 4 times 10 to the negative 19. And because it's charge, our SI unit there is going to be coulombs. Cool. Thank you. That's it for question 10 on electrostatics.